Great seeing you here again. My name is Luc de Koster, founder of the Koster Academy. And in this new video, part of our math survival guide, I'm going to talk about trigonometry. And in this first video, I will introduce triangles, specifically rectangular triangles, and we look at the Pythagorean theorem. Pythagoras was very famous for one of his formulas, and we will discuss that in this video. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's start with the first element that we have. We are looking here at the first element, and what we want to do is to define what triangles are. What is exactly a triangle? Now, when we look at the definition of a triangle is a geometric two-dimensional figure composed of three intersecting lines with length capital A, B, C, which intersect at their endpoints, A, B, C, and the intersection angles are alpha, beta, and gamma. Let's have a look how this looks when we have the triangle. So here we have the triangle with the three lengths A, B, C, the intersection points A, B, C, and the three angles alpha, beta, and gamma. Now, when we look at triangles, we have to see that the property here, and we can prove that quite easily, is that the sum of all the angles is equal to 180 degrees. Now, we typically express angles in degrees, but there are other ways to express angles, and we will look into that later in these videos. So what we see now is that we have a special type of triangle, and that's a rectangular triangle. And with the rectangular triangle, we see that one of the angles, typically gamma, is set at 90 degrees. We call this case a rectangular triangle, and we have the same elements A, B, and C. But what we now see is that based on the property alpha plus beta plus gamma is 180 degrees, gamma being 90 degrees, we can now say that the sum of the two angles, alpha and beta, is equal to 90 degrees. When we look at the Pythagorean theorem, we're going to look into the rectangular triangle. It's used typically in this type of triangle, and we see that the square of the longer side, we also call this the hypotenuse, is equal to the sum of the squares of the other two sides, the rectangular sides A and B. So A and B being the rectangular sides, C is the hypotenuse, so we can say that the square of C is equal to A squared plus B squared. This is a very important theorem in trigonometry, and we're going to use it later to define some other formulas. Now, when we look at the angles in a rectangular triangle, we see that for all triangles, the sum of the three angles is equal to 180 degrees. And in the rectangular triangle, with gamma equal to 90 degrees, this becomes alpha plus beta is equal to 90 degrees. This means that we can say that alpha is 90 degrees minus beta, and beta is 90 degrees minus alpha, which also means that alpha and beta are complementary angles. When we look at the angles, we can also express them in radians. Typically we use degrees, but we can also use radians. And when we say radians, we say that we express them with pi equal 3.14, and 360 degrees is equal to 2 times pi. Now we can say that alpha plus beta plus gamma is equal to pi, and with gamma equal to pi over 2 or 90 degrees, we can say that alpha plus beta is equal to pi over 2, which is exactly the same what we did before, but now we have everything expressed as radians. We now say that alpha is pi over 2 minus beta, and beta is pi over 2 minus alpha. When we look at special rectangular triangles, we can also say that C is equal to 1, and typically we express this see as being r, the radius of a circle. And here we see that circle. We have A, B, C, or R, and we find here the figure of that triangle in a circle. This is the trigonometric circle that we are going to use to define the angles later on. We can also say that r squared is a squared plus b squared. When we divide both sides by this, or we say that r is equal to 1, then we say that a squared plus b squared is equal to 1. When we look at the trigonometric circle, we can also define the different angles. So here we have the circle, which makes a full circle, 360 degrees, or 2 pi. So we see an angle of 0 degrees, 90 degrees. This is the first quadrant. Then we have 90 degrees till 180 degrees, which is the second quadrant. And then from 180 to 270, we have the third quadrant. And finally, we have from 270 to 360 degrees, we have the fourth quadrant. And when we look at angles, we will see that the properties and the signs of certain formulas change depending on which quadrant the angle is situated in. We also have the direction of the trigonometric circle, which is counterclockwise. The next thing we're going to do is looking at the definition of angles, and we have to make a difference between positive and negative angles. Positive angles, first of all, we have the intersection point, points A, B, C, and the angle goes from B to C in counterclockwise direction. That's the definition of a positive angle. When we look at a negative angle, we have the same, but now the direction is counterclockwise, which means it's in the other direction, and in this case, the angle beta is equal to 0, is negative. Now what we can do also, we can add positive angles, so we add angles, and we have two angles here, alpha and beta, and when we take the first one, we take alpha, and then we put the second part, beta, starts from the end point of the first angle, so we put the segment A2, B2 on A1, C1, which gives us this, and then we have the angle alpha plus beta. We can also do this when we have negative angles, or we have angles with opposite signs, so alpha is positive, beta is negative. So we have those two cases here, A1, B1, C1 with alpha, A2, B2, C2 with beta, but we see that beta is now in the other direction. So what we take first alpha, and what we do now, we take the second element and we put the segment A2, B2, which is the starting point of the angle beta, we put that on the end point of alpha, which is A1, C1, and we get this result, and we find alpha plus beta here. The next thing is some exercises that we can do. The first exercise is the application of the theorem of Pythagoras. We have the sides A, B, C. We have 3, 4, and we want to calculate C. So we know that A squared plus B squared is equal to C squared. We put there the numbers, so we have 3 squared plus 4 squared is equal to C squared. We know that 3 squared is 9, 4 squared is 16. So now we have the sum is 25, and C squared is equal to 25. We take the root, and we see that the side C is equal to 5. The other thing we can do is looking at angles and radians. Now we know that 2 pi is equal to 360 degrees. We can say now, when we want to know x in degrees and transform it into radians, so we have 2 pi times x in degrees divided by 360, and we can say that 180 degrees is pi, 90 degrees is pi over 2, 45 degrees is pi over 4, and now we can find for 36 degrees, for example, we can say for 36 degrees, we can say this is 2 pi over 10, and this is equivalent to pi over 5. We can also look at 47 degrees, so we have now 2 times 47 times pi divided by 360, which is approximately 0.2611 pi. So that's it for this first video about trigonometry. We will be looking into more examples, more exercises, more information that will be very valuable. Anyway, that's it for this video. I thank you for watching, but don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you, and I'm looking forward to seeing you in our next videos. Bye bye.